Okay, here we want to start solving the second question, alright? So we have 2x over x plus 4. This is greater than x minus 2. So we want to solve, or we want to find the values of x that satisfies this inequality. Okay, so in the previous question, we did it and it was very, very interesting along the way, and we solved for a very nice interval for that, okay, where we talk about the open intervals and the closed intervals. Okay, here we are going to still apply the same technique, alright, but I'm not going to do any graph on this one. We'll just have to simplify this a little bit and see what we can do at the end of it, alright? Okay, great. So what I would like to do is to be careful with this. I would like to simplify this first, so I would like to move these ones on the right hand side of the inequality to the left, alright? Okay, great. So we will just move this will become negative x and this will become positive 2. So we are going to have 2x over x plus 4, then minus x, then plus 2, and in fact on the right hand side we are just having 0. Okay, the next thing I'll do here is to get a single fraction, right? So I would like to get this denominator to be for everybody, and that will be by introducing some stuff, right? Okay, I will rewrite this in another way, which is the same thing. This is 2x over x plus 4, right, minus x plus 2, minus x minus 2, right, over 1. So I have a kind of factorized, this is negative x and this is positive 2, so I factorize the minus negative 1, which is here, and here I'm having positive x and negative 2 in the bracket, such that if you multiply this backwardly, this will be negative x and this will be negative times negative 2, that will be positive 2, so we get it back. And take note, as if the fraction is actually, there are actually two fractions now, where the denominator here is just 1. So I'm going to get a common fraction, or a common denominator, and I would like this one to be. So what I would do here is to go ahead and multiply the top and bottom by the new denominator, that is this one, x plus 4. So by multiplying the top and bottom by the same thing, we know we are just multiplying by 1, alright? So that this and this can just cancel and we are just left with what we had originally. So we are just multiplying by 1, that is this over this, alright? Okay, so you see here that this and this are actually the same now. If you multiply something with 1, in fact it is just that thing. Okay, so the next thing I will do is to follow this up over here. Well, since we have the same denominator, we can actually pick 1, right? And we have here x plus 4. Then in the numerator, we have 2x. Then we minus it with, well, here I would like to multiply this bracket first. So we have x times x, that is just x squared. We have x times positive 4, right? That is positive 4x. Then the next thing we have there is negative 2x. And the next thing we have there is just negative 8. Alright? Great. Negative 2x and then negative 8. So in the denominator, let me write this well. We have x plus 4. Okay, great. Let's go ahead and simplify some things, right? Okay, so we see 4x minus 2x, in fact, that's just positive 2x. So we're going to have 2x minus x squared minus 2x plus 8 divided by x plus 4. So what I've just done there is, I simplified this one, 4x minus 2x, that is 2x, alright? And then multiply this negative throughout, so that will be 2x minus 2x, then negative x squared and negative 8. Okay, so we see that this and this are equal, but they are opposite in sign, so we just delete them, and we now enter with 8 minus x squared over x plus 4. And originally, we had it to be greater than 0, right? So we still move on with that. Greater than 0, greater than 0. Okay. So this is a nice place to look at things in a very analytical way. Okay. Well, let me stand this way. We want the whole fraction to be greater than 0. The numerator and the denominator combined together, the whole fraction, okay, to be greater than 0. Now, this fraction should not be equal to 0 and it should not be less than 0. So as always, I would like to find the numbers, okay, that when I plug in them in here for x, it will give me 0 equal to 0 strictly, and I'm going to remove them. I will look for numbers that when I put them here, it will give me something less than 0. In fact, that's not really necessary, but that is also one of the points that we don't need, alright? We don't need any point that will give us infinity, that is, undefined notation where the denominator will be 0. So in any fraction, the denominator should not always be 0. So the denominator should not be 0. The whole thing should not be equal to 0. Alright? Great. Now, the whole of this fraction will be equal to 0 if and only if the numerator is equal to 0. Alright? Okay, we are not dealing with limits. So the only thing is to consider the numerator. It should not be equal to 0. So that means that if 8 minus x squared is equal to 0, which value of x will make this to come to pass? Well, we have to solve for the value of x, alright? So here we will have minus x squared is negative 8. So we multiply through both sides by negative 1. We have that x squared is equal to positive 8. In fact, which value of x, or the next thing we'll do here is to go ahead and take the square root of both sides. So we square root both sides, we have that x should be positive and negative square root of 8. Okay. So by a study of sorts, we know that when we have the square root of 8, we can reduce this to an obvious irrational number. Okay? This can be rewritten as positive and negative 2. Let me put this down. This can be written as positive and negative 2 root 2. Right? That is the square root of 8 is the same thing as 2 root 2. Because square root of 8 is square root of 4 times 2. Alright? And this is the same thing as square root of 4 times the square root of 2. So the square root of 4 is 2 times the square root of 2. Square root of 2 is an irrational number. You can't reduce it further. So we just put it down as 2 root 2. Alright? So that is it. That is just a little reminder for you. Okay, so that means that x can be positive 2 root 2 or negative 2 root 2 because of the square root. And because x is an unknown, not really because of the square root. Okay, so with these values, this will give us 0. So we don't need them, alright? We don't need negative 2 root 2. We don't need positive 2 root 2. So I put this down. Negative 2 root 2 is on the left-hand side of positive 2 root 2, alright? Okay, well, this kind of values are called the salient point. The next thing we will consider is the denominator. The denominator should not be equal to 0. Because if it is equal to 0, we will just be having an infinity. That is, this divided by 0. You don't want that. So which value of x will make this denominator to be 0? The value of x there is minus 4. Because for the denominator to be 0, it means that x plus 4, that is the denominator, is 0. This means if you move x 4 to the right hand side, you're going to have minus 4. So this means that x is minus 4. That will make the denominator to be 0. So we don't want that. We do not want that. So because of that, we will exclude negative 4. And negative 4, good enough, it lies on the left-hand side of negative 2 root 2. So this is just negative 4. 2 root 2, okay, it is less than negative 4. So negative 4 will be, 2 root 2 is less than 4. So negative 4 is now less than 2 root 2. Negative 2 root 2. Alright. You know, if you have a number that is less than the other number and the both of them are positive, the negative case of those numbers will be inverted. Okay, so we now have these points. So we now have to test them. We pick a number that lies on the left-hand side of negative 4. We pick a number that lies on this interval. So this shows, this is to negative infinity, right? Negative infinity. And this one goes to positive infinity, right? We pick a number here, we pick another number here. Okay, to test which of them will satisfy what we really want. Okay, maybe I can give a little room on top so that when we are computing, we just look at it in a nice way, right? Okay, I will not have to clean this. This was 8 minus x squared. Now let's pick a number here, -5, right? Remember already we do not want all these points because they will not satisfy our inequality. So we pick -5. Now we plug in -5 for x. So -5 here, square, will give us positive 25. 8 minus 25 will give us -16 on the top. And on the bottom, -5 plus 4 will give us -5 plus 4, that is -1. Good enough. -16, right, divided by -1 is going to give us positive 16 because negative and negative will cancel, and we just have 16 divided by 1, which is 16. And if you plug in -5, it is going to give us 16. That means that, and 16 is greater than 0, that means that this interval satisfies what we want. Alright? The next interval is between -4 and -2. Which number is here? 3 is here. Alright? 3 is here. Because 2 root 2 is actually less than 3. So -2 root 2 will be greater than -3. 3 is here. So if you pick 3 from here, plug it into this expression on the left hand of the inequality, we're going to have -3 squared, that is positive 9. Now 8 minus 9 at the top, that is -1. Sorry, 8 minus 9 is -1. Then on the bottom, -3 plus 4, that is positive 1. We are having -1 divided by positive 1, that is -1 as a result. And -1 is not greater than 0, rather -1 is less than 0. So this interval does not satisfy. So we mark X for that. Alright? Okay. The next thing is this other interval from -2 root 2 to positive 2 root 2. 0 is here. Right? 0 is here. So we can pick 0, we can pick 1. We can pick 2 itself. We can pick -2 as well. We can pick -1. So I would like to pick 0. 0 for x here, you're going to have 8 minus 0 squared, that is 8 minus 0, which is 8 at the top. And at the bottom, we have 0 plus 4, which is just 4. So 8 divided by 4 is 2. 2 is greater than 0. In fact, this makes sense also. Now, on this other hand, just looking at it, we can see 3, we can see 4, we can see 5. In fact, let's just pick 3. Okay, so 3 squared is 9. 8 minus 9 is -1. 3 plus 4 is 7. -1 divided by 7 is less than 0. So this fails. Alright, so we have the intervals that satisfy this and that. And in fact, that will help us to write down the interval. That will be, finally, we're going to have from -infinity to -4, and -4 excluded, union. So from -infinity to -4, then the C interval satisfies, that is from -2 root 2, -2 root 2. Remember that is excluded to 2 root 2 itself, which I excluded because this 2 root 2 will make us to have equal to 0, which we don't want, and this -4 will make us to have infinity, which we don't want also. Okay, so this inequality stuff is actually very tasking, but it is very nice, right? So this is the interval. Don't worry about the straight writing, but that is very nice, right? Okay, thanks for watching, and please subscribe to my channel.